3VNC GU10. Today we are conducting an experiment about the applications of dynamic vibration absorber. Did you know what is dynamic vibration absorber?
Don't know.
Alright, let me explain to you. The dynamic vibration absorber are based on the concept of adding or attaching a secondary mass to a primary vibrating system, such that the secondary mass will dissipate the energy and reduce the amplitude of the primary vibrating system. In reality, there are a lot of applications of dynamic vibrations absorber, but in our experiment we only focus on the vibration of the ship.
Hi, I'm Nina. I'm going to talk about the rolling problem of a ship. Did you know that rolling of a ship is a rocking of a floating vessel caused by the wave or any other external forces? The rolling is characterized by the amplitude, period of frequency, and the phase shift of oscillation relative to the external forces exerted by the ship. The problem is that when the ship stops spinning, it will sway greatly due to the wave. The vibration that happens due to the rolling will cause the passenger to feel seasick and strain. Therefore, in order to overcome the vibration problem, the DVA are applied where it will absorb and neutralize the vibration that happens to the ship.
Hi, I'm Tom. Now we discuss about the principle of dynamic vibration in the system. So basically, the dynamic vibration in the system is same as the mass member system. We simplify the rolling ship model into a simple model like this.
As we can see, the ship is rolling like this. The total mass of the ship is shown as the M shape. The stiffness is the water stiffness K. The damper is the string that prevents the ship from moving in C. Since the wave is moving, so this is the force vibration, and the force is equal to this equation. The ship is swaying in the displacement x. The equation of motion for this system is equal to this equation. After derivation from these equations, we can sketch the receptance graph for this system.
Hi, I'm Andy. There are two cases of the rolling of the ship to reduce the vibration.
For the first case, additional mass, which is the rock added onto the ship rigidly. So, the spring mass damper model will look like figure 8. Based on the theory, the receptance graph will have a look like this. By increasing the mass, natural frequency of the system will be reduced. Therefore, the vibration will be reduced. Let's look at the second case. Additional mass added onto the ship but with spring constant and damper constant. The system will have 2 degrees of freedom, with also 2 equations of motion. To reduce the vibration of primary system, secondary system will act as the dynamic vibration absorber, which the natural frequency of secondary system coincide with the excitation frequency. In order to be effective, they must be designed with proper mass ratio and the spring must be designed to have sufficient strength to absorb the energy of the primary system.
Hi, I'm Chad. I'm going to add this system up.
We have 3 different cases: empty boat, mass boat, and mass spring damper boat. Let's compare the video record for all cases. From the video, we can clearly observe that the vibration for the boats have been reduced from the left to the right. For the case of an empty boat and a mass boat, the result can be illustrated in a force versus frequency graph, where for case number 3 for the mass spring damper boat, the result can be illustrated in a transmissibility versus frequency graph. For the case of an empty boat, it's a single degree freedom of system. It only contains 1 mass, 1 damper, and 1 spring. Hence, the graph is like this. For case number 2, which is the mass boat, we added a loader mass, and now the graph will shift to the left. The added load decreases the transmissibility, and the vibration system will now fall in the isolation region. For case number 3, a mass spring damper boat, where now the system is a 2 degree of freedom system. The mass spring damper acts as an absorber. It will absorb the vibrations from the boat. Therefore, the boat becomes more stable compared to the first 2 cases. In conclusion, the boat will yield and vibrate less because DVA acts as an absorber and absorb the vibration from the primary mass spring damper system.